Hi everyone, welcome to this lecture. So in this lecture, we will learn about the four important metrics that can be used to evaluate the performance of any classifier. So these metrics are accuracy, precision, recall, and F1 score. So in the previous lecture, we learn about the confusion matrix and we calculate the accuracy from the confusion matrix. So we can see that we can easily calculate the accuracy of a classifier if we have a confusion matrix, because the accuracy is the ratio of correct classification divided by the total number of classifications. So we have already calculated the accuracy from the confusion matrix. So in this lecture, we will also learn about three more metrics other than the accuracy. These are precision, recall, and F1 score. And we will see how we can calculate these matrices with the help of confusion matrix. So like accuracy, we will calculate precision also with the help of confusion matrix. Similarly, recall will also be calculated with the help of confusion matrix, and F1 score will be calculated with the help of precision and recall. So let's start study each of them. So the first important metric is the accuracy. Accuracy is the most intuitive performance, and it is simply a ratio of correctly predicted observation to the total observation. So we can see that in accuracy, we have a ratio of total correct guesses over total guesses. And we see in accuracy, we use every element of the confusion matrix, that is true positive, false negative, and true negative. So in this way, we can calculate the accuracy of a model and we can measure the performance of the model. But there is an accuracy issue. There is an issue with the accuracy if the data set is biased. Biased means if the labels are not equal. The situation is that if we have a data set with only 1% positive label and 99% negative label. So what will happen in that case? In that case, if the model decides to predict everything as a negative, it will still have a 99% accuracy. So what does it mean? If I give a test sample to a model and that test sample is a positive labeled sample, but model has decided that it will produce a negative prediction for any kind of input, even then its accuracy will be 99% correct. So in that case, if the data set is biased, accuracy is not the exact or precise representation of the performance of a model if the data set is biased. In that case, we need another matrix which is known as precision. So the problem with accuracy comes when the data set is biased and we have approximately 99% negative labels. In that case, what model can do? Model can cheat us if model has decided to predict everything as a negative, even then its accuracy will be 99%. In that case, accuracy is not a true representative of a model performance. So we need a precision in that case. So what is precision? In precision, precision is the ratio of correctly predicted positive observation to the total predictive positive observation. Here, there are total positive guesses and how many of them are correct. So this is the ratio of precision. So in precision, the numerator quantity is a true positive and the denominator quantity is the sum of true positive and a false positive. So sum of these two quantity become the total positive guesses, and how many of them are correct, that will give us the value of precision. So precision solve the issue of accuracy with biased data. So if your model is classifying everything to negative, now its precision is 0. So in precision, there is nothing about the negative class. All the classes or all the components are positive. So if our model has decided to predict everything as a negative, its precision is 0. So what is happening right now is that after calculating the accuracy, it is important to calculate the precision, especially if the data is a biased data where the labels are not equal in number. So in that case, the accuracy will not be a true representative, but we have to calculate the precision as well in order to avoid the misleading that can come from the value of accuracy. Now, there is also an issue with the precision. So the precision does not paint the entire picture. It will not tell you anything about the negative labels. So if we see in the precision equation, all the labels are positive or all the information is about the positive guesses. So there is nothing about the negative labels. So what will happen in that case? In that case, precision can be defeated by a classifier if it just makes one correct positive guess and does not make any more predictions, then the precision is 100%. So what happens if model predict a one correct positive guess, that is the true positive, and after that it stops predicting anything? In that case, the precision is 100. So what happens if this value is 1 and this value is also 1, that is our correct positive guesses and total positive guesses are equal? In that case, precision will be 1, and in terms of percentage it will be 100%. So if we have only one sample, if we give one sample to the model, or basically if model predict just one sample and then it stops doing any further prediction, in that case that one sample will be the correct positive guess and that will also be the total positive guess. In that case, this ratio will be 1 and we get the value of precision equals to 1, and the percentage value will be 100%. So there is also an issue with the precision because it is not telling anything about the negative label, especially the false negative. So this issue is solved by another metric known as recall. Now look at recall. Recall is the ratio of correctly predicted positive observation to all observation in actual classes. So basically, if we see, there is a one element different in recall as compared to the precision. In precision, we have false positive value here, whereas in recall, we have a false negative value here. So basically, actually, this value is a positive value, but model has classified it wrongly as a negative. So that's why we call it that the sum of true positive and false negative is basically a total positive labels. So out of total positive labels, how many labels are correctly classified or guessed by our model? It will give us the value of recall. So if we see the equation of precision, here we have total positive guesses, and in recall we have total positive labels. So that is the difference, and we can see that here also the false negative label is taken into account. So it solves the problem of just making one correct positive guess. So now if our model is only giving the value of TP or a true positive and it is not giving any false negative, that is if a classifier make only one correct positive and the rest of all are negative, then in that case this quantity will become so large as compared to this that our recall value will be nearly equal to 0. So the problem of the precision is now solved with the recall because we have added the representation of negative labels as well. Now recall is different as it takes the negative label into equation. It asks how many. So this is the definition of recall. It asks how many positive labels you found out of all the positive label that is exist. So this is the definition, that how many true positive and how many positive labels you predict correctly out of the total available positive labels. Now there is an issue with the recall. If classifier predicts everything as a positive, then recall will be 100%. That if we pass 100 sample to the classifier and it is giving every sample as a true positive, now in that case recall will be 100%, which is not a true representative of a classifier. That is, if false negative is 0 and everything is classified as a positive label. Previously in the precision, the problem was that model decided only one correct positive. Now the problem with the recall is model is classify everything as a positive. In precision, model classify a one sample as a positive and then it stops doing prediction further. But in case of a recall, it classify everything as a positive. In that case, there will be no false negative term and the ratio will be 1 in case of recall as well, and we will get the 100% recall. So we do not need 100% recall, 100% precision, neither we need 0 recall or 0 precision. In that case, in order to avoid this problem of recall and precision, we need the fourth metric, which is F1 score. So F1 score is the most important metrics because if any of the recall and precision is 0, your F1 score is 0. So this is the equation of F1 score, and we can see that in the numerator we have the multiplication of a recall and a precision, and then we have multiply by 2, and here is the sum. Now in multiplication, if any of the recall or the precision is 0, our F1 score will also be 0. So that is F1 score is more important than the accuracy, whether our data is a biased or unbiased. So we can see that F1 score is the weighted average of precision and recall. This score takes both false positive and false negative into the account. Intuitively, it is not easy to understand as accuracy, but F1 is usually more useful than accuracy when you have uneven class. So if you have uneven class distribution, that is, you have a biased data, in that case, F1 is more important. F1 score is more important than the accuracy. So accuracy works better if false positive and false negative have similar cost. That is, you have similar numbers of false positive and false negative. That is, your data is balanced or it is unbiased. On the other hand, if the cost of false positive and false negative are different, it's better to look at the precision and recall. And finally, it's better to calculate the F1 score. Now, this was our fourth metric after accuracy, precision, and recall. And we can see that it is important because it is taken into account everything. It is taken into account recall and precision. If any of the value is 0, it means F1 score will be a 0. So this F1 score is very important. It represents the true performance of a model classification, whether your data is a biased or an unbiased. Now, in F1 score, we are using harmonic mean, so it punishes the extreme values more. The thing is, if a classifier with precision 1 and recall 0 will have 0.5 arithmetic mean, while 0 harmonic mean. So this equation is called the harmonic mean of recall and precision. Now, why it is important? Because if any of the recall or precision is 0, its harmonic mean is 0. But on arithmetic mean is different. Arithmetic mean will be the sum of precision and recall divided by 2. It is like the mean of two numbers. Like if I have two numbers A and B, so the arithmetic mean will be A plus B divided by 2. Similarly, the arithmetic mean of the precision and recall will be precision plus recall by 2. So what is the disadvantage with the arithmetic mean? So if we have a recall 0 and precision 1, or we have a precision 0 and recall 1, we will still get F1 score 0.5 if we use arithmetic mean. Therefore, we are avoiding arithmetic mean and we are penalize our model more if any of the precision and recall is 0. Therefore, we are using the harmonic mean in order to calculate the F1 score of the model. So in this lecture, we learn about these four important metrics which are used to evaluate the performance of a classifier. We can see that we need confusion metrics in order to calculate accuracy, precision, recall, and F1 score. We also learn that the F1 score is more important metrics. It will give you the more better representation of the model performance because it is taking into account everything, that is precision, recall, and it works equally well whether your dataset is unbiased or biased. If your dataset is unbiased, in that case, accuracy also works well. But in the case of biased data, accuracy is not giving us the true picture about the model performance. So for that unbiased data, we need to calculate precision, recall, and F1 score. So what we will do basically, now for any kind of data set, it is important to calculate all these four metrics. So I hope you understood the concept behind accuracy, precision, recall, and F1 score in this lecture. Thanks for listening, and I will see you in the next lecture.